In section 4 of quadrilaterals, we're going to focus first on kites. And kites are cool because they are symmetrical down this one part of the middle. And we're going to use this as the key to everything we do with kites. Remembering the symmetry is going to be definitely the most important part. So we start out with the kite K-I-T-E, very clever here, at the left. And we're told that T-I-E, so T-I-E, this inner angle here is 80 degrees. So this inner angle here is 80 degrees, and that's only half of it. And then KT is 8.2. So KT is this entire cross beam going here. It's 8.2. So we got to answer all of these other things. Now, we could look at these one at a time. My strategy is generally to go for the picture, and let's just fill in the picture with everything we know to be true, and then we can just find all the things we need later. So let's try that. We know that everything in this picture is going to be symmetrical. So whenever we see something on one side of the dashed line, we know it's true on the other side. I'll even just highlight that line of symmetry again. So if we have TIE is 80 degrees, so this is 80, I'll even write it in again. We know that this is also going to be 80 degrees over on this side. We also know down at the bottom that we have a 28, which is going to give us another 28 degrees right next to it. Now, since it's a quadrilateral that we're looking at, we have 360 degrees to go around. We could look at it that way, but we also know that kites have this cool property of forming a right angle with its diagonals. Kind of like a square or a rhombus, a kite can do that too. So if we know that we have a right angle here and we have 80 degrees up on top, that leaves us with 180 minus 80, which is 100, minus 90, which is only 10 degrees. And of course it's symmetrical, so it's going to be the same over here as well, because this is also 90. And like most good intersections of 90 degrees, all of these are going to be 90. And so if we have a 28 down here, we have 180 minus 90, which is 90, minus another 28. And when we take that away, we get 62 degrees. So that leaves us 62 up here. Good old symmetry leaves us with another 62 degrees. And now let's move on to some lengths. Let's see what we're given for lengths. We're told that this whole thing is 8.2. So that means, I'm going to switch colors here for lengths, that half of that, each side of this is going to be a 4.1. 4.1 and 4.1. Let's see what other lengths we have. It appears that we do not have any other lengths at the moment, so we'll just have to work with what we've got. So now, angles wise, it's going to be a lot easier to go back and figure out all these problems. So KIC, KIC, that's going to be 80 degrees. KIT, KIT, so the whole big angle up here is going to be 160. CET, C, E is down at the bottom, T, so it's going to be this angle coming up here, that's 28. KET, K down to the bottom and all the way up here, this whole big angle down here. We have the 28 plus 28, it's 28 times 2, and that's 56 degrees. KCI, I is up top, so KCI, we know those are right angles, so that's 90 degrees. Length of CT, that's from the middle over here, we already marked that as 4.1. And then KT all the way across, I believe that was given to us in the original problem here, and that is going to be 8.2. So you can see that although it was a little bit of work to follow around all those angles and sides early on, by doing that work initially, it made this process of finding all these angles and sides incredibly easy. Last part down here says if Ki is 12, what is IC? So let's switch colors for that. If Ki and I is on top. So if Ki is 12, what is IC? IC then is this part right up and down in the middle. And if we look at our symmetry, there's nothing our symmetry is going to do to help us. Our symmetry would tell us that we have a 12 over here, but it does not tell us anything about that third side. The only thing that can help us here is the fact that we have a right triangle. And I'm going to redraw this off to the side just so we can more clearly see it with all the stuff going on. We have a side with 12. Down here we have a 4.1, and we have a right angle. So our 12 is our hypotenuse, so we're going to call it A, and we'll call this side B, and then that side would be C. So do our Pythagorean theorem, and I will write that over off to the side where we have some room. 4.1 squared plus b squared equals 12 squared. And now let's multiply this out, so you'll want to grab yourself a calculator. And when we plug in 4.1 squared, we get 16.81 plus our b squared equals 144. We subtract our 16.81 from 144, and we're going to be left with b squared is equal to, and that's going to be 127.19. And then we just have to take the square root of that in our calculator. When we do that, it's going to round off to 11.3 for side B. So the answer is, what is IC? IC is going to be about 11.3.